Good morning, everyone. I'm Samantha Borisoff, climatologist with the Northeast Regional Climate Center, and I'm just going to briefly go over some of the current conditions that we've been seeing, kind of how we got here and where we're still at. So this is starting off kind of showing the peak drought conditions in different parts of New England. And what I really want to point out is the evolution of the drought, how, oh, there we go. Okay. So in September, late September, kind of the peak part of the drought for Maine, southeastern New Hampshire, much of eastern Massachusetts. But then as the months went on, by mid-November, we saw drought conditions ease in this part of New England, but you can see that it spread south and west, starting to encompass northwestern Connecticut, parts of western Massachusetts. So really, there were kind of two peak parts of the droughts depending on where you're at. So September for the kind of the northern part of New England, and then towards November for the southern part of New England. Here's where we are as of last Thursday. You can see conditions have definitely improved across much of Maine. We still have lingering moderate to severe drought across southeastern New Hampshire and eastern Massachusetts, with, of course, the lingering extreme conditions down in northwestern Connecticut. So while we have seen kind of this general trend of slowly improving conditions, we definitely still have drought across New England. Now, how does this drought compare to past periods? That's a question we get asked a lot. Well, one way that we can look at that is through a thing called PDSI, or the Palmer Drought Severity Index. And basically what you're looking at here is for central Massachusetts, which on the map right up here, this central Massachusetts region, for August through November of last year, that 4-month period. And what we're looking at is the green areas, the green bars right here are showing wet periods. And these kind of orangey colored bars are showing drier periods. Now here is last year and that drought, and you can see the PDSI is about 3.5, just past 3.5 or so. And if we look back through, what we're seeing is, here we go, it is one of the worst droughts that we have seen, at least to the 1960s, if not the worst drought since the 1960s. Here's that big 1960s drought that's kind of the drought of record. But if we compare it back past that, you can see there's some similar droughts in the 30s, 40s, 50s, and 60s. So really, for central Massachusetts, this is one of the worst droughts that we've seen, at least since the 1960s. Similarly, in Connecticut, you can see this is region number 2, central Connecticut. And if we take a look at the PDSI, here is the most recent, this bar right here, of August through November of last year, with a value of about -4. And this really shows pretty well on kind of the right side. So this right here is showing pretty well the dry period. We've been talking about like these longer term dry conditions. And you can see the past few years, we've seen dry conditions in central Connecticut. So again, here's the most recent year. And if we compare back, you can see this definitely is the worst drought that we've seen in the region since at least 1960, based on PDSI for that 4-month period. And then if we compare back past that, you know, we can see some similar conditions in the 1960s and the 1930s, but really, again, this particular drought that we've been seeing across the region is one of the more severe that we've seen in central Connecticut. Now, here's a look from where we were in October to where we are now. So we met back in October. We were updating you on kind of the conditions there. So where have we come since October? What you're looking at here is this brown line. That's normal, or basically the 30-year average, or kind of what you can expect from October through basically mid-February. And so this is particularly for Worcester. And what we're saying is, normally, Worcester should see about 18.76 inches. That's kind of what we would expect them to see during that time period. The green line is actually what they saw since October. And so they're sitting at about 20.29 inches, so just above normal. They're kind of hugging that normal line. So really about 1.5 inches above where kind of they should be for this time of year. However, if we take a look at Hartford, their 30-year average, this is for Bradley Airport, you can see 17.16 inches. That's kind of where they should be, but where they're sitting at is 13.54 inches. So they're still below normal for this time period. They're still lagging behind in precipitation. Now, this particular map is showing percent of normal. So basically the colors on the screen, the oranges and the reds are showing drier than normal conditions, and the yellows and the greens are showing wetter than normal conditions. So the past 90 days or so, you can see much of New England in the yellows or the greens, we're seeing some wetter than normal conditions, but then especially in Connecticut, you can see some areas of drier than normal, about 75% to near normal. If we go a little further back, past 6 months, of course, kind of the height of the drought, much of New England showing up as orange, basically showing below normal precipitation. Not too surprising considering, that was kind of the height of the drought. However, if we keep looking back the past 12 months, so for the past full year, again, we're still seeing this orangey color, so showing below normal, anywhere from about 75% of normal to 100% of normal. But then again, this kind of pops out in Connecticut. You can see they were only seeing about 50 to 75% of normal for the past year. And kind of this signature keeps going if we keep looking back. So past 24 months, past 36 months, so 2 years, 3 years, we're still seeing that there is kind of this longer term deficit. So we've been getting asked sometimes, okay, well, we've had some precipitation. Are we through? Like, why aren't we rebounding? Why aren't we out of this drought? Well, we're still lagging in precipitation on the longer term. So that's definitely one of the reasons why we still have a lot to make up. Yes, we're getting some precipitation, but we still have a big deficit and a big hole that we have to dig ourselves out of. And I'm going to end on snowfall briefly. I know Alan's going to talk a little bit more about this, but one thing that we have seen this year, we have on the left side, this is actually last season. So this was kind of what we were heading into in spring. And you can see in this particular case, the reds and the oranges and the yellows are showing below normal snowfall. So heading into last spring, we just didn't have snowfall. It was a very not so snowy season. This season, yeah, we have some snowfall. You can see the blues are showing above normal. So much of New England seeing above normal snowfall, great, but the problem is it's been warm. Obviously, 60 something today, 1st of March. So we just don't have snowpack, unfortunately, heading into the spring season. So we'll have to kind of see the repercussions of that. And I think, like I said, Alan's going to touch on that a little bit more. So I'm going to end with that snowfall information. Here's my contact information. I'm going to be here all day. So if you have any questions or anything like that, feel free to stop by and ask. So thanks, everybody.
All right, good morning, everyone. For those who don't know me, I'm Alan Dunham. I'm one of my many jobs with the Weather Service in Taunton is I'm the hydro program leader. I go ahead and work very closely with Nicole Belk, who's our senior service hydrologist. Between the two of us, we support Connecticut, Rhode Island, and Massachusetts when it comes to drought meetings. Nicole has Rhode Island and Connecticut, and I had the pleasure of going ahead and working with Massachusetts on their monthly drought task force. So when Ellen wrote to us, it's like, well, just put down what you put down for your state meetings. It's like, okay. So this is going to be fairly close to that. And as you'll tell, I'm fairly shy and fairly quiet. Okay, this is just for the month of February. You can see these colors are kind of reversed. We've actually done pretty good in February for precipitation. But as was shown earlier, and we'll reinforce again a little bit, 1 month does not end a drought. Much like Sam was saying, you get calls, well, is the drought over? You don't know how frustrating it is. After every decent rainstorm, I will get 6 to 10 calls from the media. Is the drought over now? No. How many more of these will it take to get out of the drought? I don't know. But, it is what it is, because that's maybe something we want to get into later this afternoon with the discussions, is what the scientists and science people know and the people that deal with all the time know, and what the public thinks, their perception, because I know that gets a little bit into the sociology, but I think that's something we have to start being a little more concerned with on how we're getting our message across. Talking about the SWE, this is the SWE as of the 27th of February. Now, what's kind of interesting was a week before, we had lots and lots of SWE. And by the end of February, you should be having a good snowpack. And a perfect example is once we got to those record temperatures last week, I had a corridor, and I was checked because I was working, that went from Pittsburgh all the way to the northern Berkshires with snowpack of anywhere of 18 to 25 inches. A week later, it was down to 2. And now it's pretty much completely gone. What that means is where we normally count on a good snowpack to slowly melt, recharge, go into the ground, recharge everything, it all disappears. In fact, from Ashburnham out to Rowe and Holly, they lost anywhere from 4 to 9 inches of snow in 3 days. Not with any rain, it just went. So a lot of that ran off to the rivers and streams, which has helped the stream flow, but I kind of question how much we've actually had to go back in to recharge the groundwater. And that's something we're gonna have to worry about going on. I love Sam's presentation showing how the longevity, it almost gets to the point, okay, when is the drought? Is this the drought of 2016? Or is this a drought of 2015, 16? Or is this a drought of 2014, 15, 16? Because I think we're seeing a cumulative effect each year, that because we're seeing a pattern of less precipitation in the summer, and each summer just exacerbates and gets worse and worse as we go along. So basically, here's the 6-month precipitation percent of normal, and you can see all of southern New England is, up into Maine even, is below normal. In fact, it's less than 90%, with that good area in Connecticut less than 70% on the 6-month average. 12-month, same thing. You're actually getting less than 70% in the Connecticut River Valley, in Massachusetts down through Hartford, and a little bit, even though southeastern Massachusetts had a couple of good snow events and it's had some decent precipitation. You look at the 12-month, and southeastern Mass in Plymouth County is still got parts that are below 70% precipitation, percent of normal. And then 24 months, that's what I'm saying. When did this drought really start? And of course, then you got the drought monitor. You probably see this at least a couple more times. So basically, what we deal with in our office is, one, we deal with the media and the public wanting to know, is the drought over? And then also trying to help the states and being part of those state drought task force. Now, it's going to be an interesting meeting next week, Banana, because you've got, if you look at the wells in the Northeast Mass area are doing really good. And I admit, I tried to go ahead and give my input to the drought monitor author, saying, is there any way we can cut that back a little bit? Because the streams are way up, the groundwaters are way up, but it's such a small area, and they're dealing with, national and regional scales. I don't think they can really do that. But even though the wells and everything are looking good, my fear is, okay, what if the water turns off? Because just because we've had all this rain and snow, it could stop coming. So basically, right now, for the short term, last 6 months, or actually since October 1st, we're doing pretty good. But we're just getting to the point where we're starting to recover. And it would be real easy if we follow the pattern of the last few years, because we had above normal precipitation last winter and the winter before. It wasn't much above, but it was above normal once, January, February, into March. Once we got to mid-March, the water shut off, and you just watch April, May, June, July, and then it reaches its peak the last couple of years in July and August, and that's when we see things really bottom out. So, yeah, the short term is good, but we have to be better at explaining the long term so we don't all get these questions. Well, is the drought over? Because there has to be a public component that we have to go ahead and be able to get this message out to the public, so they can go ahead and take the actions necessary.
Good morning, everyone. My name is Gardner Bent. I'm with the U.S. Geological Survey, New England Water Science Center. I'm the surface water specialist for New England, and Tom Mack is supposed to be here. I don't see him here yet, but he's the groundwater specialist. So if you have questions during today about surface water related things or groundwater, you can ask me or Tom. We'll both be here. These are just, I'm going to talk about groundwater, which is on our left. That's our Groundwater Watch webpage, and that's our climate response network. So it's wells that are generally unaffected by regulation. And then these are both shot from screenshots of this weekend. And then we have our stream gauging network, which is Water Watch, which is available online. So we'll move into it here. There we go. Okay. So what I did is, this is what conditions were back in October at our last meeting. You can see these are our stream gauges. Again, black is high flows or dark blues, reds are low flows. So you can see that the majority of these sites across New England and New York are in the lower 10th percentile of all flows on this particular day in record. But for the summer and fall across much of New England and New York, we had low stream flows, some record lows. And then this is now. So this is a screenshot of Monday. And you can see that, of course, we had some rain and we had the snow melt across the northern areas. But pretty much everything is green is normal or above normal. You'll notice here, I'll talk about this here, Long Island is still red and flows are still below normal there. And also I'm going to talk a little bit about the Cape. We don't have a lot of stream gauges down on the Cape. Both of these are very groundwater dominated systems. So there's sand and gravel aquifers. Most of the stream flow is base flow. So it's groundwater discharging to the streams. And there's not much surface runoff, or you get a rainstorm and it's going to run off. So, but down here on the Cape and through the Plymouth Carver Aquifer, even though they're not color-coded, because you have to have 30 years of data for color code, they're in the lower 25th percentile, so the Cape and especially Long Island. So, and then this is just the last, it's a 7-day look at things, and it's by the HUC 8, or Hydrologic Unit Code 8 digits. So it's the major watersheds. And you can see this is back in October, and the majority of these are below the 25th percentile in flow. So you're ranking the flows. It's the low flows. You can see up here in Maine. I think Samantha had a shot of this, but that here we are in Maine is very red, or the lowest flows. And here we are now. So you can see here again, just a little bit of, and it's just a couple gauges that they just rank how many ever gauges are in that basin. So in this case, it's a little light here, but you can clearly see Long Island being below normal in stream flow. So now I just selected a couple stream gauges. I guess it cut off the top. You really can't see. This is Ipswich at Ipswich and northeastern Mass. And you can see here, things got fairly low during 2014 and 15, but here we had record lows in the summer and early fall of 2016, but things are right now in the normal range. But I'm going to point out that you can see over the last 2 years, there's very small amounts of time that things are in the blues, which are the higher flows. So even though things are green, they can easily go back to the lower flows. And then this is Pawcatuck at Wood River Junction. And this is in Rhode Island. And I picked this one out because we talked about things even from 2014 through now being low. So at Pawcatuck at Wood River Junctions, three summer falls in a row, we had a new record low at this. So it's in the south coast of Rhode Island, but we had a new record lows at those sites. So 3 years in a row, and things are in the normal range, but they're very close to already being into the lower flows here, or the oranges and reds. And then this is a stream gauge in the center of Long Island, and we can see here that really in 2015, you can see 16, it barely got into the normal range. And even now, we're still down here in the lower 10th percentiles of flows on Long Island. Again, it's a groundwater dominated system. It's groundwater discharge that is the stream flow. So hopefully people can see this, but this is groundwater watch. And again, same color codes. The reds are low flows. This is early last October. You can see most of New England and a good part of New York we're in the reds, or lower flows, or lower groundwater levels. And here we can see a lot more green, or normal right now. We have a few blues out, and it makes a difference. Here we're looking at it's all types of wells. So it's going to be wells that are to a shallow water table or less storage, wells to a deeper water table where there's more storage, in bedrock wells. So it's kind of intermixed with those. So we'll see that in general, the shallower wells are shallow to the water table where there's less storage available, that the rainfall and snowmelt that we've had this winter, those have kind of come back into the normal range, even a little above normal. But we'll see the deeper wells where there's more storage, which is Cape Cod in through Plymouth, Carver, Aquifer, Mass, and down to Long Island, and a few hit or miss. We can see, you know, here in Connecticut, the area that Samantha was talking about, that where we have some deeper storage that it hasn't total. They're coming back a little bit, but they're still in the lower flows. So this is just this is a till well, so it's a thin deposit, and there's not much storage in it, but it's in Newbury, northeastern Mass, and we can see this is the last year. So we're in the normal range, even a little above normal, and then this is over the last 2 years, and we can see how low things got before. You can't see there's a light blue underneath, which is the max and min, but we've moved back above the median groundwater level for this time of year. And then we can see here that even though things are very low in this time period, they're still not as low as the early 60s. So this is the whole period of record. So we go from 1 year to 2 years to the whole period of record. So you can see how it kind of compares over time. And I'm going to show this for a couple other wells, but this is one with not much storage, so it was easy to recharge, and groundwater levels came up. And here we are, we're down towards, this is the Lakeville well in southeastern Mass. And so we're very close to the Plymouth Carver Aquifer area, but it's a deeper well with more storage. And you can see on the 1 year plot here that we've been well below normal for a good period of time. It's just starting to eke up, come back up. And then over the long term, this was well below normal, but we're still way below the median for this time of year. And then if we look at a comparison of 2016-17 here, we're still very low, but we had some other periods where the groundwater levels 60s here, in the early 80s here, where it was a little lower. And then this is a well on Long Island, where we have a thick sand and gravel deposit, so a lot of storage is available. But we can see here that over the last year, on the slide on the left, it's all below normal. And even now, they're going down. They're not recovering yet, but we aren't as low as the 1960s. So in conclusion, so stream flows across most of the Northeast, New York and New England, are currently normal to above normal generally. The exceptions are Long Island, Plymouth Carver, Aquifer, and Cape Cod, which are the dominated, groundwater dominated systems, where it's just groundwater discharge. Those are still on the lower side. And in general, groundwater levels in the low storage aquifers, such as the till and bedrocks in the Northeast, are in the normal range, whereas those with higher storage, sand and gravel aquifers, deeper to the water table, they're more on the below normal. But in conclusion, I think if we have a dry spring or into the early summer, quickly, whether they're the stream flows and the rest of New England and New York are normal or light, they're going to quickly go down to below normal again, and especially in those that are really groundwater dominated areas.
Good morning, everyone. My name is Deborah Bathke. I'm with the National Drought Mitigation Center in Lincoln, Nebraska. I am an applied climatologist and one of the authors of the drought map, the U.S. Drought Monitor. How many people have heard of the National Drought Mitigation Center before? Okay, a few in the room. So for those of you who haven't, the National Drought Mitigation Center is a boundary organization that was established at the University of Nebraska in Lincoln in 1995. And we serve as a bridge between science and policymakers, the media, sector-specific stakeholders, people like yourself, and even other scientists. We also co-produce stakeholder-driven science. Some of the things that, wow, I just realized the top is kind of cut off on there. Easily distracted, sorry. So some of the things that we do in addition to research is we have a variety of tools for drought risk management. And I'm not going to talk about all of them today, but they are on our website, drought.unl.edu. And they include tools for monitoring drought, such as the US Drought Monitor, remote sensing tools, an archive of drought impacts, and drought planning tools and risk assessment tools as well. But today's talk is just focused on the US Drought Monitor. So what is the US Drought Monitor? It's a weekly representation of current drought conditions. And I've made a blow up of the little key on the side. The US Drought Monitor tries to depict short-term and long-term drought designated by the L's and the S's that you see on the map. Short terms, generally less than 6 months. We're thinking on a time scale of a season or a couple of seasons, and long term, longer than 6 months. And then the intensity of drought, which are the colors that you see, which goes from D0, which is just abnormally dry. We don't consider that to be drought, just kind of a heads up as you're going into drought or maybe coming out of drought. And then the different severities of drought categories. What the US Drought Monitor isn't is it's not a computer model. Each week there's an author, someone like myself, who goes in and analyzes the data and redraws the lines on the map. The US Drought Monitor isn't a drought declaration, though it can be used as that. One of the kind of a funny story is back when Arnold Schwarzenegger was governor of California. One of the Drought Monitor authors in my office had a letter from Arnold saying that you don't declare drought, only the governor declares drought in the state of California. And he's like, I didn't declare drought, I'm just saying what the climate's telling us. So it's not a drought declaration. It's not a forecast as well. We base on what has happened in the most recent time periods, not what we expect will happen in the next week. And it doesn't just depict rainfall. The drought categories use percentiles, some of the maps that you've seen from the USGS, and I don't know if Sam showed some use percentiles. Here's what they are for the US Drought Monitors. A lot of other products out there like the USGS stream flows or soil moisture maps that use percentiles have based those on these same categories as the US Drought Monitor to make them more comparable when looking at them. Exceptional drought, that darkest red that I don't think we have any of that on the map right now, is the 1st to 2nd percentile. Extreme drought, I can't talk all of a sudden, the 3rd to the 5th, severe drought 6th to the 10th, moderate drought 11th to the 20th. So what does that mean? If we take a period of record, and I've got Boston here, I've got precipitation from looks like 1936 to 2016. So we see the highest years, we see the lowest years. This is just for summer, June through August. So those, whatever's high and low will vary depending on what time of year you're looking at. And if we rank them, this is still the wrong slide. If you rank them from the most precipitation, which if we go back was in 1955, what on the graph, what I have is Ithaca, I apologize for that. And the least precipitation in Boston was 2016. So these two lowest spots, and I apologize for these numbers, would be what we would categorize as D4 if we were looking at precipitation only for that particular time period. And everything that's in the blue, we don't consider that a drought. So when we're looking at the US Drought Monitor, we're only looking at those years that rank in the bottom 30 out of a 100-year period of record. So what does this mean for the map? In 2016, if we were looking at that summer period, that ranked as the lowest precipitation in the Boston period of record that we have. And I believe it was just barely over 4 inches for the summer months. So it fell within that 1 to 2 just on precipitation. But as I said earlier, the US Drought Monitor doesn't just look at precipitation. We look at a lot of different categories of data. They generally fall within these broader categories: precipitation, soil moisture, vegetation health, primarily from remote sensing data, stream flow, even wildfire conditions, reservoir levels, and many others. One of our other Drought Monitor authors kind of went through and calculated everything, looked at everything we looked at, and he came up with 52 different indicators that we try and look at each week when we're analyzing the drought conditions. An important part of the Drought Monitor process is this feedback that we get from local field experts. So people like a lot of you in the room. I know Sam's on the Drought Monitor listserv. Alan said he was on it. Is anyone else on that Drought Monitor listserv? Well, if you want to be, when I'm done talking, make sure to let me know and I can get you added to it. So each week when we put out a map of the drought conditions, it goes out to the now over 400 people on the listserv, and they provide feedback on it. And it's kind of a back and forth as to where are those lines going to go based on what the data is telling us and based on what people like you are seeing in your area. We also take drought impacts into that. The National Drought Mitigation Center has a drought impact archive called the Drought Impact Reporter. A lot of those come from the media, a service that combs through media reports, and then an actual person looks at those and classifies those and helps geo-reference those. But some of them also come from COCORAs. So, any COCORAs observers? One? I'm not one either, so I can't give the look like that because I'm not one either. Right, it's COCORA stands for the Community Collaborative Rain, Hail, and Snow Network. And it started, I can't remember what year it started. I used to know this because I used to be the state coordinator for New Mexico.
In Colorado.
Started in Colorado. But since then, it's been around for over 10, 15 years. It's moved nationwide, and people who are volunteers who are part of this network have these 4-inch rain gauges. They hold about 12 inches of rain. They report their precipitation every day. But one of the things we've started in the last few years is that you can also report drought impacts through that. And then those impacts get fed to the Drought Monitor authors to help us in depicting drought conditions. This is what my desk looks like the 2 weeks that I'm the US Drought Monitor. You have the road atlas over there because a lot of times people will give impact, and it makes a lot of sense to you who lives here, but from someone sitting in Nebraska, I'm like, where the heck is that? I don't know where that is. And so we get out our atlas and look at that. Lots of caffeine to keep you going. There's a cross on the phone because you don't really have time to talk to anyone or even eat lunch during those weeks. But it's pretty intense. But so we use this approach, what's called the convergence of evidence. And the maps that you see up here are all different layers. And so if it can be put into GIS in terms of percentiles, it is, as a different layer. And so we look through those different layers, try and figure out where to draw the lines. We're looking at multiple time scales. So for short term, we're looking at everything less than 6 months. For long term, everything greater than 6 months. We say 2+ years in terms of California. We've been looking for the last 5 or 6 years to see are some of those deficits recovering from it. And then, if I can find the right key, we look at the impacts to see if they're verifying what the data is telling us. And the impacts are probably the most important part of the whole process, but they're the least well monitored. So when we think about data, we think, oh, there's these gaps in data in this part of the state or this part of the state. But when we're looking at impacts, there's no real system of collecting those to let us know what's happening on the ground. And then it goes out to the listserv subscribers for that back and forth, that feedback. It would be nice if everything pointed to the same conditions at every time frame, but it doesn't. And we saw some of that with some of Alan's data. And I forget the gentleman from USGS, I forget what your name is, I apologize. But we saw that rainfall might be telling us one thing, but stream flow is telling us something else. Or rainfall at 1 month is telling us, hey, the drought's over. But at 3 months, 6 months, a year, we're still seeing deficits in it. And so what we try to do as a drought monitor author is to bring that all together and come up with a consistent story. What are most of the indicators telling us about the conditions? And I relate to your phone calls from the media. I had someone after the first rain in Connecticut said, "It's raining here, the drought's over. You people are crazy, you don't know what you're talking about." So, and well, you know, that sometimes might be true. There might be some crazy people on the drought monitor list. This is our timeline. An author works a 2-week shift. You do nothing else during that 2 weeks. By Monday, oops, I have my data cut off wrong. Monday, we try and send out 1 draft in the afternoon. We try and get it out by 3 o'clock to give the Eastern folks time to look at it. The data cutoff is actually Tuesday morning at 8 a.m. So everything up to Tuesday of the week that it's released is taken into account in that map. We get draft 2 out on Tuesday, get all the feedback where everyone tells us we're wrong, or the lines need to be, or you need to change it this way or that. Wednesday by about noon, we try and say, okay, this is the near final draft, speak now or forever hold your peace, or at least until next week. And then on Thursday morning at 8 a.m. Eastern time is when that final map is released to the public. The authorship rotates among 13 individuals from national and regional offices. So that's one of the requirements. It can't be someone at a state office, it's got to be national or regional. So right now we have the National Drought Mitigation Center in Lincoln represented, the National Center for Environmental Information and represented, the Climate Prediction Center represented out of NOAA. We have 2 authors from the USDA, and then also 1 author from the Desert Research Institute in Nevada. So we end up doing a shift 2 or 3 times a year.
All right, so as I heard the introduction, I'm from the NOAA Climate Prediction Center, and we produce outlooks from week 2 on through seasonal outlooks that carry out through the next 12 months. So I'll be describing how we produce those outlooks essentially and what is contained in those. So beginning with the shortest timescale outlooks that we produce at the Climate Prediction Center is our extended range, which begins actually with a 5-day forecast for the 6 to 10-day period. But as I said, primarily we're focused on week 2 and beyond. And week 2 is the 8 to 14-day lead operational forecast. So this period at our shortest lead is really at the interface of weather and climate. The forecast is primarily based on the dynamical model ensemble prediction systems. So those are ensembles that models are run multiple times to give us a probabilistic outlook. The forecast itself is mostly automated, and there's quality control, and some adjustments can be made by the forecaster depending on what they see in the various model forecasts and whether they believe one forecast over another for various reasons. Climate influences, which can occur at this time scale, such as ENSO or the El Nino Southern Oscillation, or any other climate influences, they play a secondary role, though, to atmospheric initial conditions and their evolution through the period, as described by the dynamical models. So this is just a sort of slide showing all the various tools, or not even all of them, but many of the various tools that we have for producing the outlooks at this time scale. We get model output from ECMWF, from the NCEP Global Ensemble, and from Environment Canada for production of these outlooks. We have various images for temperature and precipitation, as well as a fairly new consolidation of the ECMWF and NCEP Global Ensembles. We also have had for a while the North American Ensemble Forecast System, which is a combination of the Environment Canada forecast and the NCEP Global Ensemble forecast. So those 2 ensemble prediction systems in this system are corrected based on recent forecasts, recent going back several months, and then combined into the North American Ensemble Forecast System, or NAFS. We use reforecasts when we can on this time scale. We have reforecasts, that is hindcast going back multiple decades for the ECMWF ensemble as well as for the NCEP ensemble. This allows us to do systematic bias correction and to also calibrate probabilities. So the probabilities should be a better representation of the actual expected frequency of occurrence. So in other words, if we put 90%, we really truly mean that there's a 90% chance that it'll be above normal or below normal or whatever. So this is the final official outlook from yesterday, as a matter of fact, for the 8 to 14 day or week 2 period. Just a reminder that what our outlooks are generally in terciles, which is 3 categories. So that means that above normal indicates that we're suggesting that the most likely category is going to be the upper third of the climatological distribution. Below normal is the lower third. So you can see, and then near normal is shown in white without probabilities. That means that the most likely category is the near normal. Probabilities for near normal would generally be low. It's harder to predict that center category where you have less extreme temperatures or precipitation values. So we don't actually assign a probability, but it would be greater than 1/3. So we also produce, I just briefly am going to touch on that we produce a week 3-4 experimental outlook. This is not an official Weather Service outlook at this time, simply an experimental outlook. For this outlook, we're trying a different format, which is a 2-category forecast. You see the forecast there on the right. So the white areas are actually what we call equal chances, which those of you who are familiar with our seasonal outlooks will know that we have this category, which means that we're not actually changing the probabilities from equal, in this case, equal 50%, 50-50, above and below normal. We have several dynamical models for this outlook, which include the NCEP climate forecast system, the ECMWF ensemble extends out into this time range, as well as the Japan Meteorological Agency and the Environment Canada ensembles extend into this time range. But this time range, certainly also it's useful to look at climate indicators such as MJO and ENSO. We have a tool, statistical forecast system that depends on the MJO and ENSO state. We also have a constructed analog statistical tool for this. We're building the tools for this year 2018. We'll have a subseasonal multi-model ensemble known as SubX that's going to experimentally provide real-time forecasts. So moving on into the longer range timescales, which are somewhat relevant for the discussion of drought, monthly and seasonal operational forecasts. So at this time scale, as opposed to the shorter time ranges, predictability really does rely primarily on the climate modes of variability. What we mean by this is things like the El Nino Southern Oscillation, or ENSO, or the Arctic Oscillation, Pacific Decadal Oscillation, et cetera, just to name a few. For this time scale, we need coupled ocean atmospheric models that forecast changes in the sea surface temperature boundary conditions, which force the atmosphere on these longer timescales. So less significant are the initial atmospheric state conditions, but more significant are the long-term changes in the ocean and sea surface temperatures. We use the NCEP climate forecast system for this timescale, as well as a multi-model ensemble, the North American multi-model ensemble, which is a suite of models produced by research and operational centers, including Canadian seasonal forecast models. We also, at this time scale, long-term trends, decadal changes in climate are important and significant to the actual outlooks, especially for temperature. So, as I mentioned, we have the North American multi-model ensemble as one of the tools for our monthly and seasonal outlooks. Multiple operational and research modeling centers contribute to this multi-model ensemble. What you see there in the plots across the top are the combinations of all the models. The anomalies on the upper left, the probabilistic forecast derived directly from the model ensembles in the center, and then a calibrated forecast in the upper right. The models themselves are each of the images through the center and bottom row. And the lower right is a different multi-model ensemble, the International Multi-Model Ensemble, which is basically a combination of the NCEP climate forecast system, the ECMWF seasonal forecast, and the Meteo France seasonal forecast. So closing in on the calibrated probability, temperature, and precipitation forecasts. This is a system that takes the ensemble member counts that are used for an uncalibrated probabilistic forecast from the NMME. And then this system further calibrates those probabilities. As I said before, calibrated probabilities allow us to be confident in the probabilities actually measuring the likelihood of an event occurring. So the likelihood of above normal temperatures in the east, for instance, in the plot on the left. As I said, also important at this time scale is the climate modes of variability. So in particular, ENSO, or El Nino Southern Oscillation, is particularly important for seasonal forecasting. It's important not because it's the only driver of climate, but because it's a predictable mode of variability. So we have some means of identifying what the future state of ENSO will be. The ENSO forecast occurs the week prior to the seasonal forecast and the half-monthly forecast. It's done by a consensus of a team of forecasters, more than 10 forecasters, and it's based on dynamical and statistical tools. Each forecaster uses their tools of choice, and then they arrive at a consensus and determine probabilities of El Nino, La Nina, or neutral conditions. And you can see that the forecast currently shows a rising probability of El Nino conditions going into the summer months and perhaps beyond. On the right, you see some of the tools, just a couple of them. There are more. CPC consolidation consolidates the CFS dynamical forecast for ENSO, as well as 3 statistical tools. And then there's the NMME models, also produce forecasts, of course, for the sea surface temperature in the Central Pacific. So from ENSO, we know from past information what the expected outcomes are, and then we have a tool that gives us, it's a statistical guidance that gives us guidance based on what the predicted ENSO conditions are. So based on those prior ENSO predictions, we can create a probabilistic forecast simply from ENSO, and trends are also included in this. So these maps here showing for the winter months and then the spring months on the right are the forecast based on the forecasted ENSO state at the time. You can see a shift in the maps from on the left, which is primarily a La Nina forecast, and then to the right where La Nina is less significant and somewhat trends are part of this forecast, but also the future state, which is leaning more towards El Nino, plays a role in the forecast on the right. So then finally, the official outlook combines these various tools, and on the left you see the most recent March update, which is just released yesterday. And on the right you see the March, April, May forecast that was generated in mid-February. So the monthly and seasonal drought outlooks are dependent on these various seasonal and subseasonal temperature and precipitation outlooks that we just looked over. This monthly and seasonal drought outlook refer to the drought monitor, which was just described. So they're predicting tendencies in the drought based on the drought monitor for a month or for a season. Predicting persistence of the drought category improvement, which means an improvement in category of drought, or development in some cases. So the outlooks, as I said, rely on the short term to seasonal precipitation and temperature outlooks, and they consider the changes in the seasonal climatology of precipitation as well, because drought is a very long-term phenomena. So simply changes in climatology of precipitation from wet times of year to drier times of year and so on will also impact the drought. So this is the drought outlook on the left, the monthly drought outlook, I'm sorry, the drought monitor on the left. The monthly drought outlook for March in the middle, this is the just updated drought outlook for March. And then the seasonal drought outlook on the right. It should be noted that these drought outlooks are only produced with zero lead, which means that the period that they're forecasting begins the day after they're released. So the mid-February drought outlook begins in mid-February, February 16th, and extends. Actually, I wrote mid-May, but it's actually the end of May. So it includes the full 3 months as well as the period at the immediately after the release of the forecast. Closing in just briefly on the seasonal drought outlook, you can see that the forecast is generally for improvement for the Northeast region. Some of the areas where there was, so this is forecasting for areas that are D1 and above. So not the abnormally dry areas, but the areas that are actually classified as drought. And improvement in the areas where you have D1 means that drought is eliminated, and that's highlighted in the green, and then the beige areas indicate where drought is improving, but not removed. That would be the case when you have D2 or greater, that you would expect some improvement but not removal of the drought. So this, as I said, relies on a whole series of tools. Actually more tools than shown here, certainly, but in terms of forecasts, just to highlight what we mean, looking at the lower left, we have 7-day precipitation. Since the drought outlooks begin the day after they're released, we would use information that begins with the weather forecasts for precipitation for the first week, as well as precipitation and, to some extent, temperature forecasts for the second week, for March, for the monthly outlook, and the seasonal outlooks as well. And as I said, in the lower right there is an image that tells you the percent of precipitation that falls in the upcoming season from climatology relative to the annual average precipitation. So it tells you if it's a dry season coming or a wetter than average season that's coming, and that impacts changes in drought as well. Somewhat the drought forecast that's indicated in the upper right, seasonal drought forecast, is in part relying on simply climatology. The climatology doesn't change as greatly in the Northeast region as it does in some other parts of the country, especially the West, but it does play a role. And of course, even a normal precipitation forecast could mean improvement in drought conditions. And that's all. Thank you.
Good morning, everybody. My name's Tom Smirosky. I work with UMass Extension on the UMass Extension Crop Insurance Risk Management Education Program. Also here from the same program is Paul Russell. And Katie contacted me yesterday and asked me if I was going to this meeting today and said, could you cover my presentation? So I said, okay, send me your slides. She sent me the slides. And I tried to open it last night, couldn't open it. Samantha was able to open it today. So I'm going to go through the slides briefly. And then I also I just jotted down some comments this morning to kind of talk about the time frame as far as how agriculture was affected in 2016. Now, Katie was approached by the USDA Farm Service Agency back in July and asked if she could put together a survey of Massachusetts farmers to see how many were affected by the drought. Totally voluntary survey, almost 567 responses. 80% of the responses said they were affected by drought, and 20% were not affected. And you can see right now, these are the counties that were affected. Primarily, you see the Connecticut River Valley, Franklin, Hamden, and Hampshire. We're in Worcester County right now. Again, Katie's survey was done back in July. So I think if this were to be done, say in October, November, you would certainly see those numbers increasing, especially down in Plymouth County where the Cranberry area is. This is a map of Massachusetts, and you can see this area right down here, the Cranberry area. You see over to the left-hand side, the Connecticut River Valley. And as you know, if you're aware of agriculture in Massachusetts, it's all spread out. You know, we don't have the big areas like the Midwest where there's just blocks and blocks of cropland available. This was the drought monitor from August 9th, and I believe this was probably around the first time we started seeing extreme drought in Massachusetts. And you can see it's the northeastern corner. And as the season progressed, we eventually, the top's cut off there, but that's November, and you can see that it took off from northeastern Mass all the way down through the middle Connecticut River Valley into the Berkshires and down into Connecticut. And this is where we are today as of February 18th. In terms of crops affected, field crops, which would include your hays, forages, things like that, corn silage, were obviously the most affected in Katie's survey. That's acres. On the left-hand side, you see fruits, vegetables, and others were affected. Obviously, hay was one of the big ones. One thing about the hay crop I wanted to point out is that normally, when we're talking about hay crops, we're looking at like mixed grass mixtures, and usually timothy, orchard grass, and things like this. Fed out to dairy cows, to beef cows. The horse people like mixed grasses and things like that. Normally, normally first cutting, which usually is going to start mid to late May, go through the month of June, and hopefully be done by the early part of July, is generally unaffected by drought, primarily for the fact that there's usually adequate moisture in the soil coming off the winter and the spring, that drought shouldn't impact that first cutting, which in some cases might represent 65% of the total crop. In 2016, we saw for the first time that I can remember, where that first cutting was really impacted, where in some cases farmers were only getting 50 or 60% of their normal first cutting. And then obviously with the drought conditions continuing, that affected subsequent cuttings. Usually when you're talking about grass, timothy, orchard grass, you're going to get 2 cuttings off every year. If you're talking as some of the other hays like alfalfas and clover, you may get 3 or 4 because they're a deep-rooted crop. But again, those subsequent cuttings were affected. You see the impact cranberries. That's showing about 1,000 acres of cranberries were affected at the time of the survey. Now, there's probably about 14,000 acres of cranberries in Massachusetts. And as I go through my kind of calendar events, you'll see how cranberries were affected even greater. These are some of the other crops in Katie's survey. Obviously, the big one that stands out here was potatoes. And then just mixed crops, Christmas trees, flowers, and so on. So that takes care of the survey, but a couple of notes I kind of jotted down. One of the things, if you're a farmer, the worst thing you can hear in the media is that there's a drought or a severe storm, because especially if you have a farm stand, and if you have a farm stand, you're expecting people to come out to your operation. If you have a U-pick operation, you're expecting people to come out. the minute it gets out on the local news that there's a drought and agriculture's impacted, a lot of people see those stories and say, you know what, the farmer doesn't have those strawberries or the peaches and things like that, and it affects their business. So sometimes it's hard to get farmers to admit to what the problems they're facing in things like with drought and severe weather, because it does impact their business. Now, going back in 2016, the first bad weather event that affected agriculture in Mass was the February 14th freeze, where we hit, in some cases, about 20 below. I know it's not drought related, but that was like the first event. What that freeze did is it basically wiped out all the peaches in Massachusetts, and probably most of New England. There might have been some peaches, say, in southern Connecticut or Rhode Island, but Massachusetts was wiped out. Peaches are an important crop if you're a tree fruit producer, because it's one of the first crops to come in. There's a high demand and farmers get good prices. The next weather event that affected tree fruit producers, primarily apples, was we had a cold stretch in early April when the temperatures dropped down to about 20 degrees after the buds started coming out. And so, you know, talking with some of the apple producers, yields ended up coming down, but also as the year went on, you know, it's really hard to measure what impact did drought have on that crop as well. So, and then also the February 14th freeze, did that have any impact on the apple? So it was kind of a combination of things. We move into May and June, and this is where I mentioned about the hay crop starting to be affected. Again, generally in agriculture, May and June aren't serious concerns for drought, but this year they started picking up. And so as the summer went on, there was a need for the crops, had a need for more irrigation water and so on. And so farmers, a lot of farmers do have irrigation. They've invested quite a bit of money into irrigation. There's even a few of those big center pivot systems that you see in the Midwest. There are a few on the Connecticut River Valley. A lot of the farms who have U-pick operations for strawberries, apples, cherries, they've put in drip irrigation systems. And then a lot of farmers just have reels or overhead irrigation that they try to make use of. One of the problems in Massachusetts, though, is that a lot of the land is rented. Now, if you have a 100-acre farm, 200-acre farm, and it's all in close proximity, irrigation is, you can utilize it, it's not that much of a problem. But if you're renting a 10-acre piece 5 miles down the road and there's no access to any type of surface water, that can be a problem. So, you know, we've seen that as a problem going in. As the summer progressed, we also started seeing problems with livestock water. Farmers who either had most part wells, all of a sudden those wells started running dry. And in some extreme cases, they had to start hauling water in for their livestock. Now, there are several USDA programs that are available to help assist with situations like this. But again, that's something normally producers don't have to do. And then as a result, now if your well's dry or you're not getting the recharge, you're in a position, well, do I need to do something, you know, for the coming year? And again, there are some USDA programs to provide some assistance there, but funding is not always readily available. And that's a big concern of producers going into the growing year. Cranberries. Cranberries obviously rely on water, and Paul's more of an expert on cranberries. So Paul, if I don't cover this right, chip in. Cranberries use a lot of water to basically flood the bog so they can harvest the crop. and the water comes from reservoirs and things like that adjacent to the cranberry bogs. Well, again, all of a sudden, that surface water, those ponds, reservoirs are empty or certainly down significantly from normal. And so farmers had to put a lot more effort in terms of moving water from reservoir to carry out their harvesting operations. Right, Paul? Correct. Okay. And, you know, some of the other crops that were affected, for instance, like late cabbage. A lot of vegetable farmers will put in 2 plantings of cabbage. They'll put in a spring planting, usually as soon as they can get onto the land, and then come back with a second crop that they'll put in July or so. Now, generally in cases like this, they're doing transplants, and when they're transplanting, they do have water on the planter to help get the plant started. Hopefully they have irrigation, but one of the things we found this year, or we heard from a lot of the producers, cabbage growers, was that, you know, come August, the month of August, when usually the heads are forming, because of the drought, the cabbage just kind of grew, it just stood there and the heads never formed. So that was one crop, certainly that got impacted amongst others. And so now, that was 2016. It really wasn't a good year. And I think the big question on the minds of a lot of producers in Massachusetts, you know, what's going to happen in 2017 and what can I do as a producer, you know, to maybe improve my irrigation systems? Can I get a more efficient system in there? Do I need to dig some wells? Because again, we heard a lot of, you know, from vegetable producers across the state whose wells ran dry, and now all of a sudden that they used for, not wells, they're surface ponds. Those were used for irrigation sources of water weren't there anymore. What do I do? Because I don't want to have to go through the same thing again this year. They do have some time to put in, you know, wells and things like that, but a very short window before they really need the information or need the irrigation water for their crops. So.
My name is Elizabeth Osowski. I'm a program coordinator with the National Integrated Drought Information System. We are a multi-agency partnership that is led out of NOAA, and I am based in Boulder, although I am from Hingham, Massachusetts, and my mom lives in Hull and my dad lives in Connecticut, so whole family's in Rhode Island, extended family, so it is good to be home. Oh. I hate Max. Yes. The National Integrated Drought Information System, aka drought.gov, is the website many of you may have seen already or visited, is a system that was created by Congress in 2006. As a bit of background, in 1996, the Western Governors Association wanted to change the way that the country approached planning for and preparing for a serious drought emergency. That led to, in 1998, the creation of the National Drought Policy Act, which established a commission that made recommendations to Congress on a national drought policy. In the early 2000s, that proved to be politically very difficult to pass comprehensive drought policy legislation. And so it was sort of then we took the approach of kind of taking piecemeal, non-controversial approaches within that broader set of recommendations and pass separate pieces of legislation of smaller initiatives. One was the creation of the National Integrated Drought Information System. And the vision behind NIDIS is that it will create a national drought early warning system for the country. And what that system is a system that collects and integrates drought information and then communicates that information on impacts, on conditions, and on drought early warning planning to decision makers, to practitioners, stakeholders in communities across the country, the general public, that we take, basically, we go from a more reactive approach to a proactive approach to planning and preparing for and responding to serious drought emergencies. So like I said, we were authorized in 2006 and reauthorized in 2014, largely with bipartisan support, 190 Republicans, 170 Democrats. We are up for reauthorization next year, and so we are already starting to think about what is the information that on a national level we need to be sharing with decision makers about what's taking place in the US, and in particular here in the Northeast as well. And within the public law, it really codifies and explains very explicitly for us and gives us a mandate to build this drought early warning system, because better informed and more timely drought related decisions lead to reduced impacts and costs. And so one of the things that NIDIS is working on at a national level is measuring the socioeconomic impacts of drought. That is something we're taking a look at now, to the extent that it also applies here in the Northeast as well. We realize this mission by looking at 5 separate issues that all inform a drought early warning system. And the one that I'm going to talk about this morning is regional drought early warning systems. But I should also note that we also fund integrated research and monitoring, drought planning initiatives. We do this largely by leveraging and coordinating existing partnerships and networks. So we are here today with partners. Ellen in the NRCC and the American Association of State Climatologists and others have helped along the way, the National Weather Service, in allowing for this sort of event to happen. And we manage drought.gov. The idea behind research-based integrated information systems and climate information systems is that we first make sure that we have a coordinated group, a coordinated partnership of stakeholders representing sectors, so that we have folks at the state level, at the local level, at the tribal level in some parts of the country, the private sector, that we're engaging them as well, that we map decision making, and that we enhance prediction capabilities. We make sure that we're coordinating federal drought research, and that we are building capacity for stakeholders, you all, folks in the community, to enhance our response to drought moving forward. This is really what we want to avoid. And the cartoon says, in layman's terms, there are 23 flushes left. And that's a Georgia climatologist. Across the country, NIDIS manages 8 drought early warning systems currently. The first was in the Intermountain West, this lower gray area. And as you can see, we started in the West and we are expanding eastward. We really didn't have any intentions of coming to the Northeast anytime in the recent past, but obviously we had a situation in 2016 that brought us here. There are 5 key components of any regional drought early warning system. So if you dig down into any one of those regions that I just showed you, you will find a team of stakeholders networked. And among those stakeholders are folks that we are interacting with on a regular basis that are coordinating on these 5 areas that were defined by stakeholders in each one of the regions as being the critical areas of need when there is a drought in their region. Observation and monitoring improvements, better data, prediction and forecasting, supporting advances in prediction and forecasting that is tailored to local situations on the ground, better planning and preparedness resources, better drought messaging, so communication and outreach, and then interdisciplinary research, and making sure that the research that's being done in academia is not just for research sake, but has practical applications on the ground. The objectives of any regional drought early warning system, again, is to provide a forum for us to talk, identify gaps and needs. For instance, what was the biggest information need and gap that you experienced in 2016? What were those answers? And I will share them in just a few minutes. Develop an understanding of what are the current observation and monitoring networks, and making sure that we're sharing them with those who need that information. identifying the economic, sector-specific, and geographic needs for future monitoring, prediction, planning, and information. And this regional approach allows us to be responsive to the specific geographic and hydrologic circumstances on the ground. It's more important that the regional drought early warning systems in, say, the Intermountain West or the Pacific Northwest, that those boundaries are drawn by watershed. That is less relevant out here. And so there are different political circumstances, different watersheds that are obviously under serious litigation around the country. And so we need to customize and make sure that each regional system is able to be responsive to local needs. Here are just some practical examples of what NIDIS, with its partners, helps to deliver to communities. So in the Pacific Northwest in September, we brought together drought coordinators, planners, and climatologists throughout the Pacific Northwest in a workshop to talk about gaps in drought indicators, indices, and triggers, and how we incorporate those improvements into state drought planning efforts. In the Missouri River Basin, we worked with the Big Sky Watershed Corps to conduct a drought planning course. We also work heavily with tribal constituencies in the Missouri River Basin. In the coastal Carolinas, we helped to fund and support the development of a coastal salinity index, working with USGS gauges in coastal river systems to monitor drought conditions. How does this all get started? It really gets started with a very non-glamorous planning process, which to a certain extent is kind of underway in the Northeast and why we are here today. Taking a look at what are the current conditions, where do we go from here, what are the needs and gaps in information, and developing a plan, a 2-year plan of how we tackle the problems that we're seeing. You know, and this, I want to reiterate, I know I am beating a dead horse here, but these are all stakeholder led. So NIDIS is not coming in with a prescription for how we do this. We are listening, writing down what's transpiring, and out of that shaping the plan and how we go from here. But these plans are taking place throughout all of the 8 current regional drought early warning systems that exist right now. And, you know, with Gantt charts and who's going to deliver on what and how, and agreements are being made. What this looks like in year 1, and so you can envision how this might look in the Northeast, that we would scope out what a Northeast drought early warning system would look like. What information exists? How is it being coordinated and used? What are the 2 to 3 critical issues facing the Northeast at the moment? Characterize and communicate drought risks across timescales for these critical issues. And then in year 2, we really begin implementation of the drought early warning system. We consider seasonal trends. We develop drought subportals, and by that I mean on drought.gov, that there's an online resource where this information is being captured and shared with people who need that information. That we are really methodically making sure that the information and the resources that we are identifying are being incorporated into preparedness and adaptation plans. And then establishing a network. So what repeated information do you need? Do decision makers need? Does the general public need? Does the ag community need? And making sure that we are setting up a schedule so that we can provide that information and going about this methodically and with a plan. And I'll end with just a picture of, to date, what NIDIS has been up to in the Northeast. Like Ellen said, and like many of you know from having attended the event in October, that originally started with a call that we got in early September from Congressman Moulton's office out of Massachusetts' 6th district. That was obviously in the D3 map that was up on the drought monitor back in August. The constituents in his district wanted more information, better resources. And we reached out to Ellen and the NRCC. We all kind of came together and planned the October event to just provide some foundational information and resources and talk about impacts. And now we're here. And the outcomes of today will inform two sort of tangible documents that we think will then live on in creating a system. One is a one-pager that we hope to be able to share with you by the end of next week, along with the presentations that have been produced today. That one-pager is really written for decision makers that will capture what has transpired here, what we think is the path forward in a nutshell. 6 weeks from now will be a more in-depth report of what we've heard today in the breakout sessions and where we think we need to go from here in building a drought early warning system for the Northeast.
So I am Jessica Spaccio. I'm a climatologist with the Northeast Regional Climate Center. So I work with Sam. We're located on the Cornell University campus in Ithaca, New York. So I'm going to kind of go over some of the tools that and products that we've put together and that we work on that are available for drought information. So this is our website, and we started, I think it was in July or August. Oh. Okay, a little closer. Is that better? Okay. So in the summer, when the abnormally dry conditions started spreading, we saw, okay, we're going into a drought in the Northeast. We need to start looking at this. We need to start providing more information for the people in our region. So we already had a drought page, but we decided that we needed to do more than just have what we had up there on the usual basis. So we have this now Northeast Drought Update page. We update it weekly. Sam and I, every Thursday when the drought monitor is released, this page is updated. Our website is nrcc.cornell.edu. When you get to the home page, there's a big drought monitor map. You click on that and it brings you to this page. So it's really easy to find from our home page. So we have, an update on the drought monitor conditions, what have changed from the previous week to the week that we do the update. I think on the next slide I have, yeah, so this is some of the information that you'll find on that page. It's a lot up there. There's precipitation maps that we do, departures from normal, to kind of see, how things are changing. We show the last week's precipitation, how much we got over last week, and then departures over different time frames, a 60-day, a 90-day, a year, to see, how are the departures changing throughout the time scale. We also have information from water resources. So we have USGS maps on there, stream flow, and groundwater conditions that we post on there. So weekly that's updated as well. And we have text to go along with that to explain those maps a little bit and how things have changed from the previous week. State declarations, we have a little a box up there for each state to see what declarations, and then highlighted in red each week are the changes. So you can see what's changed from the last week. So after task force meetings, like when Massachusetts has theirs, we're listening to see what they've changed in their declarations, and we post that here as well. We also include near the bottom page outlooks. The green map here is a precipitation outlook. This is not current, this is from the summer, but so we include the next week's precipitation outlook, kind of a week look ahead. And we also have we use the Climate Prediction Center's 8 to 14 day outlook, precipitation and temperature maps we post as well, with an explanation, again, so kind of current conditions and looking ahead. So every week this gets updated. On our drought page, we also not only have that main kind of update page that we do weekly, we have a lot of information that's always there. It's kind of hard to see, but there's a drop-down box of some of the different products that are available on that site. So we look at different periods of drought, different percentage of time in drought. And this graph here is a percent of area in drought. So this is for the state of Massachusetts. It's a time series from 1900 through current day. So this is a percentage of the state that was in a moderate, severe, or extreme drought. So you can see the current, this summer there was a bigger block, and then obviously back in the 60s you see a lot of the drought there, but just to give you a time series of drought picture there. And that is updated monthly. This is an example of what we have done for New York State. We had requests from some local representatives in New York for something specific for New York. So just an example what we did to New York, and we could possibly do this for other areas if needed. So we did this weekly during the height of the drought. As things have improved, we're now doing this bi-weekly. This is a PDF it gets emailed to some interested stakeholders, and it's also on the website as well. So similar to the webpage, we have the drought monitor maps. We compare the current week to the previous week. We also have the precipitation departure maps and outlooks. And then also we have, it's a little bit covered, but in the back we also have water resources maps as well. And we also have a little piece where we kind of look at a few stations specifically that have been hit and look at how their departures are and how their precipitation has looked over the past week. So this is kind of how we've tailored it specifically for New York, and it's something we can look for doing for other areas as well. Other resources that we have on our website and that we offer every month, we have these great monthly webinars that Sam really hosts a lot of that, and we have a piece that we do, and then we also have different people that come in and do presentations for us. We had one just yesterday on drought. We had USGS presenting with us, and every month we have a different topic. We covered El Nino. Last year we were in the height of that. We'll cover flood outlooks during the spring, and so we really kind of tailor it to what's going on and what's needed and what we hear from people. So those are done monthly. You can sign up for those on our website, and they're also recorded and hosted on our website, so you can look through and see other webinars that we've done and view them. The presentations are there, so if you don't want to watch the whole webinar, you can go through and look at the presentations. We also have done special reports, which are just basically 2-page PDFs that are posted on our site. We did one after the drought meeting in October. That's on our website, so you can see a recap of what was done there. And we have quarterly reports that we do for the Eastern region, as well as the Great Lakes region and the Gulf of Maine region, and those are posted there as well. We really have a lot of resources available. So this is an example of something that we did. We partnered with Climate Smart Farming, which is at Cornell University, and so we used our programmers and our data, because we worked with NOAA and the National Centers for Environmental Information, and we archive data for the entire Northeast. So we have a lot of data. So we worked on this irrigation scheduler. So it's this specific tool that there was a need for, that we worked on developing, that shows the water deficit and whether it's a good time to plant trees or whether there's stress going on. So whether you need to irrigate or not, and kind of incorporate some forecasting as well and look ahead. So we have a lot of opportunity to work for specific needs and to help develop tools. If there's not something that's available already, we're happy to work with our partners and develop something specifically where there's a need.
All right, well, I am going to really quickly go through just a few slides showing what you all shared as the biggest information gap you experienced during the 2016 drought. So we've had about 100 people across New England and the Northeast participating in these meetings. And here were the responses, which we try to make sense of, pairing them into different groups. The biggest takeaway is that we expected that lots of folks would say forecasting, better forecast is exactly what we need. But actually almost 50% said better observation and monitoring data. Followed by prediction and forecasting, and also a strong pull for improved drought messaging and information dissemination in one way, shape, or form. Coordinating and sharing drought information across platforms, across state lines, across watershed groups, you name it. Planning and preparedness support among decision makers. And I'll go into what was in those categories. So in better observation and monitoring data, better information on fish kills and wildlife impacts, both short and long term, better historical data, a comprehensive understanding of reservoir conditions. And I should note that these results include New York State as well. Information on drought severity and impacts locally and regionally. Understanding the severity of water tables. Interpretation and melding of multiple drought indicators. and a private wells reporting system. How many had gone dry? Another big takeaway was improving drought messaging and drought communication. Better communication from water systems, people wanting to know why were restrictions enacted, who enacted them. Better messaging on drought from the press. Consistent and effective dissemination of information to the public. Sharing this information and putting it into a climate change context. Recipients of assistance had a hard time finding out where to access data, what assistance was available, and there was a lack of information concerning regulated water sources to municipalities and ag. Coordinate and share tools across platforms, so real-time sharing of drought information at a regional level, coordination among state drought forecasting tools, and current conditions compared to targets from other water system reservoirs. In prediction and forecasting capabilities, improving long-term hydrologic state forecasts, prediction of rainfall for the future, reliable short-term forecasts, trends for wildfire planning and suppression purposes, anticipated impacts to wildlife, skillful long-range forecasts and impacts to infrastructure functions and the economy, and long-range stream flow predictions for planning condition-dependent fieldwork. Ensure better planning among decision makers. So one comment was the state's delayed response to the drought. Not sure what state that was. The time between drought task force meetings. Drought awareness at community-based watershed groups was lacking. Available assistance to farmers in need of water, and preparedness information on how to improve water conservation in soils.